Hi, everyone. What we're going to be working on in today's lesson are some foundational skills that you'll need for the rest of this chapter. What I want you to look at is this function that I have here, which is a cubic function, and I have a line that cuts through that function in two places, which is called a secant. I want you to imagine if I took this point Q and I kept dropping it lower and lower and lower so that the height difference between P and Q got reduced. So for example, if I dropped Q down to here, this line would now look something like this. Okay, so Q is much closer to P, but of course it's still a secant line because it is intersecting our function in two places. But eventually, if I could just take that point Q and drop it down, down, down all the way, this line would no longer be a secant, it would be a tangent line. And a tangent line intersects a function in exactly one point. And that's what I want you to think about as we're going through today's lesson, because we will be finding the slope of the tangent line at a particular point. In other words, between 2 points when the height approaches 0. So let's go ahead and let's talk about some things you'll need to know in this chapter. You absolutely have to memorize them. First of all, a plus b, quantity squared, will always turn out like this. A squared, 2 times the product of a and b plus b squared. And when we cube a binomial, I'm not sure if you remember binomial expansion from pre-calc, it's always going to look like this. A cubed, now notice in the next term it's a squared, a to the first, and then we don't have an a to the 0. And here we don't have a b to the 0, then we have b to the first, b to the second, b to the third, with our middle coefficients being 3. So you have to memorize that. And slope is old news, but you may see it written like this at some point. And all that is saying instead of x sub 2, y sub 2, we say the height is a function of the x value that we substitute in. And the same thing here. It's just a slope written in function notation. So don't be thrown when you see that. Okay, so let's get down to business here. You have used some of these skills already. You've seen some of this, but we're going to be putting many, many things together today. So first of all, we're given a function. We know this to be a parabola. If we're going to put it in function notation, all that means is to swap out the y for an f of x. So our function is now in function notation. Now what we're going to do is we're going to calculate f of a, which just means substitute a everywhere you see an x in the function. Nothing has changed. We just substitute that value in. A little bit more challenging is now we're going to substitute a plus h in everywhere we see an x. So we have a plus h squared plus 4 times a plus h. And this is why I told you to memorize, because if you don't even have to think about this, it'll be really good for you in terms of saving time. Distribute that 4, and look at what we have. We have that expanded for us. Very nice. So we're kind of piecing this together. And now what we're going to do is we're going to take f of a plus h, which is this, minus f of a, which is this, and divide it by h. So it's going to look something like this. I'm just copying this f of a plus h. Kind of did it ahead of time, so we could just copy it. Now it tells us to subtract f of a. So we're going to subtract a squared plus 4a. And we're going to divide all of it by h. Now, let's clean it up a little bit. First thing I see, plus, and then distribute that negative inside. What should happen every single time is every term that's in these parentheses should cancel with a term here. Negative 4a cancels with positive 4a. let's look and see what that leaves us with. We have 2AH plus H squared plus 4H all divided by H. And do you notice something about every single term? Well, every single term has an H, which means we can reduce this by canceling out or dividing out an H from every single term. This is what we are left with. Now you might be thinking, well, what is that? So that is going to allow us, because we are able to simplify this, to take the limit of this as H approaches 0. Had we tried to do it before, we would have had a 0 in the denominator. But now that we've cleaned it up, we're able to take the limit, I should have written limit as H approaches 0, of 2a plus 0 plus 4, which just leaves us with 2a plus 4. And you're probably thinking, well, all right, what is that? What does that mean? Well, think back to our function that we started with at the beginning of this. This is the equation of the slope of a tangent line at a given point A, when x equals A, on our function. Okay, so again, that's the slope of the tangent line somewhere on our function. Well, now we're going to actually find the slope when x equals 3, or in other words, when a equals 3. So we'll find the slope 2 times 3 plus 4. And when x equals 3, the slope of the tangent line is 10. So that is a very steep slope. Now that we have the slope, the next thing that we'd like to do is actually find the equation of that tangent line. So in order to do that, we're going to use y equals mx plus b, but we're not ready yet because we need a point when x equals 3. So we will have to substitute 3 into the initial function. Now let's scoot back here and see the initial function was x squared plus 4 times x. So we will do 3 squared plus 4 times 3. And what we find is that f of 3 equals 21. In other words, there's a point 321 on the parabola, the given parabola. All right, so why is that helpful? Well, now that we have the slope and a point, we can calculate the y-intercept, which would essentially give us the equation of the tangent line. So we will put 10 in for our slope. We will put 3 in for our x value and 21 in for our y value, meaning the only variable is b. 10 times 3 is 30. Subtract the 30 from each side. We find that the y-intercept of our tangent line is -9, which means the equation of our tangent line when x equals 3 of our parabola is y equals 10x minus 9. Okay, let's see if it works. Let's see if that even makes sense. So I want you to again think that our function was f of x equals x squared plus 4 times x. And the equation of our tangent line is right here. So what I'd like for you to do is pause the video, either use your calculator or use your brain, and sketch this and see if it looks like we've found the tangent line for this function when x equals 3. Go ahead and pause the video and we'll see if we agree. Okay, so not the best sketch, but here's what our parabola would look like. Here's what the equation of the tangent line graphs out to be, and they intersect at the point 321 on our graph. Okay, and if you wanted to confirm that, you could pull up your table if you had both of these in your calculator, and you'd see that at 3, both the height of the parabola and the height of the line would be 21. Okay, so we just found the equation of the tangent line at x equals 3. Okay, let's go do it again. Here's what I'd like for you to do. I'd like for you to do the first 3 parts, well, actually 4 parts. So pause the video, see if you can do those parts, and then check back in and we'll see if we agree. Okay, so I didn't quite finish because I wanted to make sure you could at least check to here. Okay, and hopefully you turn this into plus a negative and a positive. Negative 2a squared, positive 2a squared. Positive 3a, negative 3a. So that should have left you with 4ah plus 2h squared minus 3h over h. And hopefully you saw that we have an h in every single term. And the most beneficial part of that is that we no longer have an h in our denominator. So if you got here, fantastic. If you didn't, go look for your mistake. And now what we're going to do is we're going to take this and we're going to calculate the limit as h approaches 0. And we can do that now that we don't have an h in our denominator. So we have 4a plus 2 times. Okay, my computer's glitching quite a bit here, but what we are left with is 4a minus 3. Oh, this is terrible. Okay, so what I'd like for you to do, now that we have that, go ahead and try the next few sections. So you're going to calculate the slope of the tangent line. So here we have this. When we're at x equals 2, and then you're going to actually calculate the equation of the tangent line at x equals 2. So remember, you'll need y equals mx plus b, and you'll also need to calculate f of 2 from our original function. Okay, and of course the slope here. So try those 3 things and let's see how you do. Pause that video. Okay, how did you do? I got a slope of 5, which is pretty steep. I had the point at x equals 2 on our function, on our parabola, to be 2, 2. And then when I substituted those values in, I got the equation of the tangent line when x equals 2 to be 5x minus 8. So now what I'd like for you to do is I'd like for you to use your calculator or your brain or both and go ahead and sketch a graph of the function and sketch the tangent line, and they should intersect at 2, 2, and of course it should look tangent and not like a secant. So go ahead and do that. Pause the video. Okay, so hopefully when you graphed it, it looks something like this. You can clearly see we have a tangent line intersecting right here at the point that we said 2, 2. We have a very steep slope of 5 and a y-intercept of negative 8. So we found it. We found the equation of the tangent line at x equals 2. Okay, let's move on. Don't worry, we have an x cubed, but we know how to expand our binomial to the 3rd power. So I want you to go ahead and do A, B, and C, and let's check in, and then we'll go ahead and have a little typo here. We'll do D and E. So go ahead and do A, B, and C, and then start the video back up. So pause that video. Okay, check out your values. Hopefully you expanded your trinomial as we discussed on the first page. Hopefully you distributed your negative 2. So as long as you have all of that right, go ahead and do D and E on your own. So you're going to stop the video. You know what to do. This all goes in first, minus this over H. clean it all up, and then calculate the limit as h approaches 0. You got this. I know you can do it. Okay, let's take a look. So I got 3a squared minus 2, which again represents the slope at any point on our curve, on our function. So now you're going to go ahead, assuming you got the same thing as me, you're going to go ahead and you will calculate the slope of the tangent line at x equals 3. Okay, so calculate the slope. And then you're going to calculate the equation of the tangent line. So go pause this video and let's see what you can do. Okay, so I got a slope of 25. When I put 3 into our original function, I got the point 321. And when I use those two values to calculate the equation of the tangent line at x equals 3, I got y equals 25x minus 54. So go ahead, again, you're going to use your calculator, graph the function, and see if it looks like, and in fact, you can check on the table, if both the tangent line and the original function contain the point 321, and take a look at it and make sure it looks like it's tangent. I'm going to sketch a video, a graph for you, but you can go ahead and pause this video while I do that. Okay, so this is what my graph looked like. Okay, and I looked on my table and I could see that I had both the function and the tangent line both contain the point 321. So things look really good. All right, everybody, have a wonderful night.